Okay, guys, we're on section 3.2, and I'm going to start by reading about an algorithm from 3.2 called the division algorithm. So 3.2 is all about synthetic division. This is going to help us for the remainder of the chapter with our subsequent sections. So you really want to try to get good with the synthetic division, okay? Now, when you first read this, it can look a little confusing. That's okay. I'm going to show you exactly what it means. It sounds trickier than what it is. So it says, let f of x and g of x be polynomials with g of x of lesser degree than f of x and g of x of degree 1 or more. There exists a unique polynomial q of x and r of x such that f of x equals g of x times q of x plus r of x, where either r of x is equal to 0 or the degree of r of x is less than the degree of g of x. Okay, now maybe, I just read that, you might be saying, what the heck does that mean? Okay, here's the idea. We're going to divide something. We're going to call it f of x, and we're going to divide it by g of x. What's going to come out, we usually call the quotient, right? That's the answer to a division problem. That's what q of x is, and r of x is the remainder, right? Because think about it, if you divide f of x by g of x and you get q of x, then these two should multiply to this, except for maybe sometimes you have a remainder, then it's a little different. I want to show you what it means just using regular numbers first with old-fashioned long division. Maybe it's been a while since you've done it. Okay, so let's go over here, and I'm going to back this up just a little bit right there. Okay, so we're going to start right here. First, we're going to do it with numbers, then we'll do it with the polynomials. Okay, so long division. If you remember, it was this thing you learned back probably in 3rd or 4th grade, and you want to do 103 divided by 3, okay? And remember, these things had names, okay? This had a name of the dividend, okay? Now, in your definition in the book, that's the f of x, okay? The 3 we called the divisor, okay? Now, the divisor from our definition is that g of x, okay? And to do the division, remember we said, okay, how many times does 3 go into 1? Well, it doesn't go in any. So then we would say, well, how many times does 3 go into 10? It goes in 3 without going over, right? And then you do 3 times 3 is 9, and then you subtracted that off. Hopefully this looks a little familiar, okay? We have 1 left over, and then we would bring down the 3. Remember bringing that down, okay? Then we would repeat the process. We'd say, okay, how many times does 3 go into 13 without going over? Of course, that's 4, okay? 4 times 3 is 12. We subtract that off, and we're left with 1, okay? Now, if you remember, that 1 was what we called the remainder, okay? And a lot of times, the way we would write it is we go up here and we write it as 34, and you might say R1. Another way is we would say 1 over that divisor, so 34 1/3. This is how we're going to do it when we do our long division and synthetic division once we get there, okay? So in this case, if you look in your book at that definition, f of x was our divisor, was our dividend, so that was the 103. G of x, okay, so g of x was our 3 right here, okay. Q of x was the quotient, that was the 34, and the r of x was that remainder, which was 1. Okay, now remember, we're going to write this 34 with the remainder over the divisor. This is the final answer. All that algorithm is telling us, okay, let's look at one more quick time, okay. F of x equals g of x times q of x plus r of x. All that's saying is, hey, we can write this 103, our f of x, as the g of x 3 times the q of x 34 plus the remainder. That's all it's saying is we can write it like that, okay? And if you look at this and you do your math, 3 times 34, that's going to give you 102 plus 1. That is true. So we just did it with numbers, okay? The same thing holds true if we're going to do it with polynomials, okay? So I'm going to do long division first, then I'm going to show you synthetic division, okay? Generally, synthetic division is easier. You can use synthetic division whenever your divisor is of degree 1, okay? You can't do it if it's degree 2, it doesn't work out. So we're going to do this in the same way we did the other one, okay? So I'm going to look at the x here, and I'm going to say, how many times is x going to x squared? Now that might seem weird when I phrased it that way. It was weird to me when I was learning it, okay? So here's what I like to ask myself. X times what is x squared? Well, then it's a little easier to see, oh yeah, it's just x, okay? And now we're going to do the same thing as when we put the 3 up here. We're going to say, okay, well, x times x plus 1, I'll do it piece by piece. X times x is x squared. Now up here, when we did that, 3 times 3 is 9, we put a minus sign. We're going to do the exact same thing here. And then I can't forget about the 1, so x times 1 is x, but then I have to subtract it off. So it's the exact same process, I'm just using variables now. My x squareds cancel, that should always happen, that first part should cancel, and I'm left with a 2x. And just like before, when I was left with the 1 and I brought down the 3, I'm going to bring down the plus 2 here. And then I'm going to repeat the process. So x times what is 2x? Well, it's positive 2. Okay, now we'll go through 2 times x plus 1. I'll do this part first. 2 times x is 2x, but we subtract it off. 2 times 1 is 2, but we subtract it off. Hey, no remainder, okay? So our remainder is 0 in this case. And this actually makes sense because if you think about it, let's write it. So remember, we can write it as f of x equals g of x times q of x plus r of x. That's what our theorem tells us, right? The division algorithm, okay? Well, my f of x is the dividend. So x squared plus 3x plus 2 is equal to the divisor, that's the g of x, so that's x plus 1, times your quotient, x plus 2, plus the remainder, but in our case, the remainder is 0. And if you actually just go ahead and FOIL that out real fast, you'll see that that's the same thing, okay? Now, I want to do the same problem, but I'm going to use synthetic division. And the idea here is that what I'm going to do is I'm going to look at this and I'm going to look at my divisor and I'm going to say, well, what's the 0 of that divisor? What can I plug in for x such that this thing will be 0? And the answer to that is this number, -1, right? That is the 0 of the divisor. That's what will make the divisor equal to 0 when I plug that number in for x, okay? And here's how I'm going to do this, okay? I'm doing the same process, it's just expedited. I'm going to have the -1. So I'm going to, what I put here, the 1, the 3, and the 2, those are just the coefficients of the x squared, of the x, and of just the number. So I'm going to bring down the 1, and then I'm going to multiply and say, okay, well, that's -1. Add them up. 3 minus 1 is 2, okay? And then I go here, 2 times -1 is -2, and I have 0 here, okay? So this was my coefficient for the x squared. When we go down here, we just take them down by a power. So this is the coefficient for my x, so this is x, and this is my coefficient for my regular number. This is my remainder, but of course I didn't have any remainder, right? So this just says my answer was x plus 2, just like I got with the long division. It's a little bit quicker though, right? Okay. All right. Let's do the same thing. Let's try a few from the book, okay? Example, use synthetic division to perform the division, okay? So I got x cubed plus 7x squared plus 13x plus 6 divided by x plus 2. So I'm going to do it in the same way. I'm going to go straight to the synthetic division. Look at your divisor, x plus 2. What is the 0? If I plug in -2 for that, that'll make that thing equal to 0. So that's what I put in the little box. And then I take all my coefficients. So 1, 7, 13, and 6. And now I'll go through and do this. So I bring down the 1, I multiply, put it right here. 7 minus 2 is 5, multiply, put it right here. 13 minus 10 is 3, multiply, put it right here. Oh, I think my remainder is 0 again, okay? So keep in mind, this represented the coefficient of my x cubed, but we drop it by 1 for our quotient. So this is now x squared plus 5x plus 3, no remainder. There's the answer to the division problem, okay? How would you verify it? Well, you could multiply this with the divisor, make sure you get that original dividend, okay? I want to do this one. It's a little bit bigger, but it is important to do one like this because there is a little thing you got to be careful about. So once again, I see that this is the 0 of my divisor, right? If I plug it in for x. And now I'm going to do my coefficients. So I'm going to start with my x to the 6th. So that's 1. Now, I don't have an x to the 5th. You have to put a placeholder for that. So I have to put a 0. These represent how many x to the 5ths I have, okay? That'd be like doing 3 into 102, let's say, and just saying, well, I'll just do 3 into 12 because the 0 doesn't matter. You see why? That's the same reason we need this 0, the same reason we need the 0 in 102, okay? So just remember that placeholder, very important here, okay? And I'm just going to continue on, and actually that's a -3, right? Okay, then I got a 2, a -6, a -5, and a 3, and I'm going to go through, do my division. So 1, -2, -2, 4, 1, -2, 0, 0, -6, 12, 7, -14, and that's going to be a -11. Okay, so let's say I start with x to the 6th. So in my quotient, I'm going to start with these. This is my coefficient for my x to the 5th. Minus 2x to the 4th plus x cubed. No x squareds. Minus 6x plus 7 minus 11, or we could say, I'll keep it as plus -11 over the original divisor, the x plus 2. So that's how you deal with the remainder, okay? Alternatively, you could put minus 11 over x plus 2, or you can put plus the -11 over x plus 2, and that would be fine, okay? So that's what we're going to want to do for that one, okay? So that's just a start on 3.2. I'll have one more video on 3.2.